Okay, okay, so we know the length and width add up to 200. So if you know the length, how do you get the width? Well, if the length is 120, people are able to tell me very quickly, well, the width is 80. How did you get that? Well, I subtracted it from 200. Subtracted what from 200? Okay? Subtracted 120 from 200. Okay, what do you call 120? It's the length. So you subtracted the length from 200, right? Now, that's a fairly complicated set of connections. Okay? It's not trivial. But if you start with a numerical example, you can kind of go along that type of chain of reasoning to figure out what you get, rather than using a formula that might or might not be right. Okay? So, again, if length and width add up to 200, then you'd be subtracting the length from 200 to get the width. And if you can say that, if you can get that into words, then you say, oh yeah, so now if the length is x, we subtract that from 200 and we get the width, right? Now there's another way that I saw at least once. Okay? A little more formally, or you could say length plus width equals 200, right? So can you, that's an equation for length, width, and 200, right? So can you solve that for width? Well, everybody can do that. So width is 200 minus length, right? And if the length is x, that's 200 minus x. Okay? Now, I almost guarantee you've seen a problem like this in your algebra courses. Okay, they were universal, or as near universal as anything I can think of. Okay? When you're trying to apply algebra to something real. So you want to make sure you can think through this. But now, okay, what's the area? What's the expression for your area? Take a minute, think it through, write it down.